Hello, good evening all.
Good evening, ma'am.
Yes. So let's start the session now. So today we are going to see some problems from week 11. Okay. So far so many sessions has happened. We'll discuss the theory part. So if you have any doubts in week 11, you can ask me. Okay. Shall we start now?
Ma'am, would you please give some brief summary of week 11 and then start?
Week 11 has been taken in 3 live sessions. So please go back and see the videos on YouTube. Again, we are not going to do the summary for week 11. It has been done on 3 classes.
Okay.
Yeah. So how many of you tried solving the problems?
Ma'am, till 11.4 I have done, not before, afterwards. Then I have to yet to solve the remaining one.
Till 11.4 you have solved, okay? So any doubt you faced 11.4?
Not exactly, but I was watching lecture 11.5, and in that I was having a doubt actually, but I haven't gone ahead, so I don't know whether there's a typo or there is some understanding which explanation has been given. So if you can check, you can go to lecture 5, 14.42. So
Okay.
in that slide, sir has explained different philosophy of testing, and in that he has explained about p-value, and in that second point he is mentioning that if p-value is low enough, choose to reject H0, otherwise accept HA. But my query was, rejecting H0 itself means accepting HA, right? So how can it be otherwise? So I was wondering.
Okay, just hold on.
Yeah.
So were you present in yesterday's session?
No, yesterday I couldn't attend. Before that I was there.
Okay, so yesterday's session, mostly lecture 11.5 and 11.6 has been discussed.
Okay,
So
I'll go through
can
it
you
again.
go through it? Yes.
I'll go through it again. Okay,
Yeah.
thank you.
Okay.
Yeah.
Yeah, can I ask, like, is this related to with the p-test question you were asking?
Sorry. Can you repeat?
I'm asking to Kavita. Yeah,
Yeah,
did she
tell
ask
me.
the question about the p-test?
Yeah, I
Was it
asked about the
p-test?
slide. I asked about the slide.
Was it? Does it involve the p-test?
Yeah.
Yeah, basically, I asked the same thing. I'm telling you how I know is because even I got like yesterday's session, sir clarified that there was a typo. It should not be HA, it should be
Okay.
HA.
Okay. Fine. Okay. Thanks. Yeah.
Can you mention at which point?
At timestamp 14:42. I mean, that slide is for right from 30, I think 13 minutes. That slide is there, but I'm at 14:42 for sure. So in that, the second last line, second point in p-value.
Okay. Fine. Okay, so any doubt in the problems? Assignment?
Not so far, ma'am, for me at least. I mean, I have to go through the next one, 11.5 and onwards.
What about others? Nobody has tried the problem? No, okay. So what should we do today? If none of you have tried the problems,
You could explain the next lectures.
next lectures, you mean week 12,
No, 11.7 and
11.7 and 8.
problems. So yeah, maybe a revision.
So okay, before we start that, I want to know if those lectures were not covered yesterday.
Not sure, ma'am, actually.
Anyone who attended yesterday's session, can you let me know?
Ma'am, I
if,
think 11.7 and 8 will be covered tomorrow.
sorry.
I think it's going to be covered on the next session. Venkatesh sir is going to take.
Okay, so the problem part has not been covered, right?
Yeah.
Okay, so okay, let's start with Z-test problems then. So all of you are familiar with how to use the Z-test and everything, right?
Actually, not, ma'am. If you could just explain it quickly.
Okay, so let's do it with the help of problem. That will be better.
Okay.
So there are overall some 6 problems. I will do it 3, 4, and I will suggest you to do some. Okay. Let's start with the very simple basic problem. Okay, so we'll start with a very basic problem. So this is from lecture 6. So there the problem number 1 states that suppose X is normal, okay? Normal with mean mu and variance 9. Now you have taken 16 IID samples of X, okay? So you have n equals 16 and you are taken, let's say, X1, X2 up to X60 IIDX. The observed sample mean is 10.2. Okay, so this is what we have observed. Observed sample mean equals 10.2. What conclusion would a Z-test reach if the null hypothesis assumes? So the null hypothesis is given to be mu equals 9.5 against the alternative that mu is greater than 9.5 at a significance level of 0.05. Okay, so a very quick question here. What kind of test? So what kind of test is this? Is it right-tailed or left-tailed or both-sided? Both-tailed.
Right.
Is it right-tailed?
Right. Yes.
So okay.
Right tail.
So you can easily identify that this is a right tail test. Okay. Now to use the z-test, like what is z-test for mean? Can you mute? What is z-test for mean? I mean, when do you use the z-test? So you have
when I do hypothesis testing for mean, ma'am.
Yes. So whenever we do the test for mean, so test for mean, I'm not sure if all of you have gone through week 12 lectures. So there are two tests. Please mute. So much noise is there. Okay. So I'm not sure if you have gone through week 12, but you are going to study two kind of tests for mean. So one test is z-test and other kind of test is t-test. So this you are going to study in week 12 and this you have studied in week 11. Now what is z-test for mean says, if you have a null hypothesis of the kind mu equals mu naught, so always we take null hypothesis to be simple hypothesis. Okay. And the alternative can be of the kind either mu greater than mu naught or mu less than mu naught or mu equals mu naught. So if let's say if this is your mu naught, okay, so mu greater than mu naught, right? This is mu greater than mu naught. So this is called the right tail test because it is at the right side of the mu naught. So we call it right tail test. Right tail. Similarly, this is going to be left tail. And this is going to be both sided test. Okay.
Ma'am, it is not equal to mu not equal
Sorry,
to
sorry. Mu not equal to mu naught. Okay. Now you have three kind of tests that we can take in alternative. Then there is something called test statistic, right? So what test statistic do you use? Generally, we use sample mean, right? If given a sample, we can use sample mean as the test statistic. So, and what is the test? What is the test? Anyone? Let's say the test is right tail. Okay, I'm taking alternative to be right tail test where mu is greater than mu naught, and the test statistic to be sample mean. So what should be our test?
X bar times mu is greater than mu.
Sorry, can you?
Reject H naught if
T is greater than C.
T is greater than C.
Reject H naught if T is greater than C. And T here is test statistic, right?
Right.
And what is C? What is C?
Critical value.
C is critical value, right? So all this we need to know. Now we have to check whether we are going to accept or reject the null hypothesis at a significance level of 0.05. Okay. So let's say I have taken the test statistic to be sample mean and my test is going to be reject H naught if T is greater than C. Fine. So the solution, let's say I am taking my test statistic T to be X bar and the test is that we reject H naught if T is greater than C. Okay. Now what is the formula for alpha? What is alpha? What is alpha?
Significance level.
Significance level. So how do you define the significance level?
It is reject the null hypothesis if the hypothesis is true.
Reject the null hypothesis
If
given the null hypothesis is true, right?
Yes.
Probability of making type 1 error. Yes.
Yes, probability of making a type 1 error. So that is our significance level. Now, significance level here is given to be 0.05, right?
Yes.
So alpha equal probability that you reject H naught given H naught is true, okay? So when are we rejecting H naught? We are rejecting H naught if T is greater than C and T is X bar, right? So we are saying X bar greater than C, probability X bar greater than C, given mu equals, what is H naught? What do you mean by mu H naught true? Mu equals 9.5, right? Now you would like to convert this X bar greater than C, like this X bar, to the standard normal distribution, right? So to make it to the normal form, to capital Z form, what you're going to do, you are going to subtract the mean and divide by standard deviation, correct?
Yes, ma'am.
So X bar minus, what is the mean of X bar?
Mu 0.
9.5 itself. Yeah, mu 0.
Simple mean, yeah.
9.5.
9.5.
Hmm.
Okay. And you have to divide it by standard deviation.
Well,
So that is 3 by 16, 3 by root 16. That is 3 by 4.
Sigma upon root 10, right?
Yeah.
So it is 3 upon root 16. So same thing we'll have to do on the other side. So it becomes C minus 9.5 divided by 3 by 4, right?
ma'am, just I have one confusion here. In the earlier lectures, we used to use root n sigma. No? Then why are we dividing here?
Root n sigma.
Sigma.
Yeah, so let's not get confused in this. See, the expression will you're saying from the CLT, right? So
Yes.
there you had said, like if samples are IID with mean mu and variance sigma square, then X bar minus mu divided by sigma upon root n is a normal distribution, standard normal distribution. Same thing is S minus n mu divided by n under root n of sigma is normal 0, 1. This expression and this expression is the same thing. Like, can you convert this to this form? So S is what? S is x1 plus x2 plus up to xn, right?
Yes.
Now, so you're writing x1 plus x2 plus xn minus n mu divided by sigma under root n. And what is this expression? This is x1 plus x2 plus up to xn divided by n minus of mu divided by sigma divided by under root n.
Yes.
Now you do, in this expression, you divide both numerator and denominator by n. Okay.
Okay.
So if you do this, numerator part becomes x bar
Bar
minus mu, and denominator part becomes sigma by root n.
Yes, ma'am. Got it.
Both are similar, right? Both are same.
Yes, ma'am. Yes, ma'am. Got it.
So this is what we got here, and we know that this is nothing but our normal 0, 1, right? So we can write this as Z, which is greater than C minus 9.5 divided by 3 by 4. Okay, and this is F1 minus FC of C minus 9.5 divided by 3 by 4. And significance level is given to be 0.05, correct? Now you just have to solve this expression.
Madam, can I interrupt here once, please?
Yes.
Can you show the other slide where you actually put it as x bar is sum by n, and then you
There.
here when x bar is sum by n, that part is clear as far as the numerator is concerned. But the denominator, why is it root n? Because you're taking another root n to the other side. How is that, madam?
You're talking about the first one?
The one on the right side that you had written, sigma by root n.
Here.
Yeah.
Okay. So this I'm writing from here, right? Sigma by root n. See, how sigma by root n came. So we had x1 up to x1, x2 up to xn, IID normal, IID distribution, IID x, right?
Yeah.
IID x, where expectation of x was mu and variance of x was sigma square.
Sigma square by sample.
Sorry?
Sigma square by n for the sample, you mean?
No. I mean, I'm just saying x1 up to xn is IID x. Okay. Expectation of x is given to be mu and variance of x is given to be sigma square.
Correct.
All right.
Yeah.
So using CLT, we know that that x bar, right? X bar minus mu divided by sigma upon root n becomes normal 0, 1. And how does this sigma upon root n comes? So this is nothing but standard deviation of x bar. And what does this mean? Mu, this is nothing but expected value of x bar, right?
Yeah.
This is how we get this.
Thank you. Thank you very much.
Now coming back to this problem here, this becomes fz of c minus 9.5 divided by 3 by 4 equals 0.95, right? And we can take this fz to be on the other side, and it becomes fc inverse of 0.95. Okay. So basically C comes out to be 3 by 4 times fc inverse of 0.95 plus 9.5. Okay. So this value, so can somebody check what is this value? fc inverse of 0.95?
1.65.
1.65.
1.65. Yes, so this is 1.65. This is very standard value, right? So after you solve this, you get C to be 9.73. Okay. Now come back to the test. So the test said reject H0 if T is greater than C, right? So what is T? T is X bar, and X bar came out to be 10.2. 10.2. And we should have rejected H0 if T bar, that is 10.2, when it is greater than C, right? So from the C value that you have calculated, you can easily say that this T is greater than C, that is 9.73. Okay. So should we reject our H0 or should we accept our H0?
Reject.
We should reject our H0. So this is the answer. So you are rejecting your H0. It means you are going to say that your mu is greater than 9.5. Is the question clear to everyone? It's a very simple, it's a very basic Z-test problem.
Yes, ma'am.
It was done yesterday.
Sorry?
It was done yesterday.
It has been done. Okay, can you let me know what all has been done yesterday? Because I asked.
This problem and more 2 subsequent problems.
Okay, the next problem and the next problem is done, right? Okay, so.
Ma'am, this one was done, and then photo, that there is
desired,
yes,
that was done.
Yeah, and this one.
Normal mu 36.
Yeah, this one which you solved right now, right?
Yes.
And after this app, that face recognition.
Yes.
Yes. That
And
was
which is the next one? So
done.
you are saying only 2 problems were done.
Yes.
Okay.
Plus one, I think plus one. One more was done. I think that one, where mu was 8.5 something.
Mu is 8.5. Okay. Was problem number 3 done in the yesterday's class? Where the question is, suppose X is normal in mu with mean mu variance 36. Was this problem done yesterday?
One double-tailed problem was done, ma'am. That's what I remember. Double-tailed distribution problem.
I'm not able to understand what you're saying.
There was one double-tailed C problem, means double-tailed rejection region problem. That was done.
He's saying two-tail problem, ma'am. Two-tail
Yes,
problem.
yes.
You're saying about problem 3, right then?
Maybe. Just a second, ma'am.
Okay, so Aditya Singh asked that it was done, right? So basically, all the problems from lecture 6 were done. What about lecture 7? Okay, so lecture 7 was not done. So we'll start from there. Okay.
The next problem he was going to do was the vaccine hesitancy.
Yes, so it was in
It was not done.
okay. All right. So let's look at lecture 7. Okay. So the problem states that vaccine hesitancy, that is percentage of people who are unwilling to vaccinate in a town, has been reported to be 20%. So there are around 20% people who doesn't want to take the vaccine. Who doesn't want to take the vaccine. To test whether the fraction is 20%, you call a randomly selected group of 10 people and find out that 3 of them are vaccine hesitant. Okay. Now you want to check whether this proportion, whether this percentage is correct or not. And to test it, what you are doing is you are randomly selecting a group of 10 people, and from there you found out that 3 are vaccine hesitant. It means 3 people doesn't want to take the vaccination. Okay. So 3 people are vaccine hesitant. Now, what is your null hypothesis here? So what is the null hypothesis here?
It's not equal to.
Okay.
It's not equal to 30% people are hesitant, vaccine hesitant. or we can say 0.3.
Not 30, it is 20, right? You want to check.
Sorry, yeah. Yes.
So we want to check whether P is 20% or not. It means P is 0.2 or not, right? So
Yes,
null
sorry,
hypothesis is P equals 0.2.
0.2.
Right?
Yes.
And what should be your alternative?
More than 0.2.
Not equal to 0.2.
Okay, no. All right. So we have not talked about, we have not said anything more about the question. So the first question was, what is a null hypothesis? So since you have found that around 3% people are vaccine hesitant, right? So basically you are trying to check whether P is greater than 0.2.
Yes.
Ma'am, in this case, does it mean that if P is less than 2.2, then we accept the null hypothesis?
If P is less than 0.2, we accept the null hypothesis.
P is less than C, that is.
Yes.
Okay, so we just saw that if we wanted, okay, so first thing is we wanted to check whether P is equal to 0.2 or not, whether whatever has been observed or reported is correct or not, right? So H0 to be P equals 0.2, this is what we wanted to check. And from the sample to check this, the sample that you collected, from there you found that the P is coming to be around 0.3. Now, will you accept or reject the null at a significance level of 0.05 against an alternative that the fraction is above 20%? So the alternative that is given is that the fraction is above 20, so P is greater than 0.2. And the significance level alpha is given to be 0.05. It means at 5% significance level, you want to check whether you are going to accept the null hypothesis or you are going to reject the null hypothesis. Okay. Now the question is, what is the power against an alternative? Okay, first let's do this problem. Will you accept the null hypothesis or you reject the null hypothesis? Okay. So what is the test statistic that you will use?
This ratio, ma'am, 0.3.
Our test statistic cannot be 0.3. I'm talking about test statistic. Test statistic is a function of
sample. Function of sample.
Yes.
It's a function of sample.
So what function are you going to use for test statistic?
Like we took the sample of 10 people and out of them 3 are vaccine hesitant, right? So,
like in the previous problem, we used the test statistic to be sample mean. Can we use the sample mean here? Should we use the sample mean?
Yes.
Okay. So let's use test statistic to be X bar, and the test is going to be reject H0 if X bar is greater than C. All right.
Yes.
Now note that here, what kind of, you're taking 10 people, right? So X1, X2 up to X10. So can you tell me what kind of random variable it models?
Bernoulli.
Bernoulli random variable. Why is it Bernoulli?
Whether they are hesitant or not hesitant.
Yes. So this is what we're going to check. So we have 10 people, and then we are just going to check whether a person we have chosen is whether the person is vaccine hesitant or they are not, right? So it is nothing but a Bernoulli random variable. So we are modeling this as Bernoulli P random variable. So the way we are defining our xi to be, let's say xi is taking the value 1 if ith person is vaccine hesitant. Okay, so vaccine hesitant, and otherwise we are taking it to be 0. All right. So what is the, okay, so again alpha equals 0.05, and this is equal to probability that T is greater than C given P equals 0.2, right? And we have taken our P to be X bar. Okay, so what is the mean of X bar?
0.3.
0.2.
0.3 and 3 are vaccine hesitant. Mean is 0.2. Yes, mean is 0.2. Yes.
Okay, and what is the standard deviation going to be?
P1 minus P divided by N.
P into 1 minus P divided by square root 10.
Right. So P is 0.2. Again, this is 0.8 divided by 10.
Yeah.
Right. The same thing we will do on the other side. So C minus 0.2 divided by 0.16 divided by 10. Right. So this is our Z. So Z greater than C minus 0.2 divided by 0.16 divided by 10. Right. And this is 1 minus fz of C minus 0.2 divided by 0.4 divided by root 10, correct? And this is going to be, this is given to be 0.05. So again, fz of 0.95 is 1.65, right? So it becomes C equal 0.4 divided by root 10 times 1.65 plus 0.2. Once you solve it, you will get 0.4 times 1.65 divided by root 10 plus 0.2. So we are getting C to be 0.41. Okay. Now, what was the test? The test was reject H naught if X bar was greater than C.
Yes.
Okay. So what was the value of X bar given?
0.3.
3.
3, right?
0.3.
Not 3. It is not 3.
0.3.
0.3.
0.3, right? So X bar that was 0.3, it is coming out to be less than 0.41. That is C. So can we reject our H naught?
No.
No. So we will accept H naught. Okay.
And if C was lesser than 0.3, then we will reject it.
Yes. So in this case, C is coming out to be greater than X bar, that is your test statistic. So we are saying that we are going to reject the H naught, and rejecting H naught means you will have to accept your accept H.
In the lecture, sir solved it using the binomial distribution.
Yes. So
And here we are accepting null hypothesis, right?
oh sorry, accepting, yeah, initially it was right. Yes.
Yes. We will change it. Yes.
So in the lecture, instead of using the test statistic to be X bar, we are using the test statistic to be X1 plus X2 plus up to X10. So when you use this, you will get the same answer, that is accept H naught.
So it's
Both
our
approaches are
choice
correct,
whether
right?
to use Bernoulli or binomial.
So
And
this
both approach are correct.
both approach are correct. So
Yes,
basically you have to define one test statistic, and test statistic is nothing but a function of the sample. You can take anything. I can either define it as sample mean, or you can define it as sum of the sample mean, right? Sum of the samples.
Okay.
Hmm?
Okay.
Yeah.
And
So
what if
what if
C and T is equal?
what if C and
C and X bar is equal?
if C and X bar comes to be equal, okay.
Accept it.
Test statistics.
Man will accept it, I think.
Yes, yes, we will accept it. Anything below C, we will accept it.
Because it is greater than we have to reject.
Yes.
there you can accept the null. It's all right in that case. So how to find okay, so here we just saw whether you'll accept or reject the null hypothesis. Now the next question that comes in is, what is the power of the test? What is the power of the test against an alternative that the fraction is 30%? So how do you define the power of the test?
One minus beta.
Okay. So,
Reject null hypothesis given that alternative is true.
so probability of rejecting null given HA is true, right?
Yes.
Oh, sorry. Yeah. So given HA is true, what is the probability that you reject H0? So again, this is what? Probability X bar is greater than C given P equals 0.3. And it becomes X bar minus 0.3 divided by 0.3 times 0.7 divided by 10 greater than C minus 0.3 divided by 0.3 times 0.7 divided by root 10, correct? And this is going to be 1 minus FC of C minus 0.3 divided by 0.3 times 0.7 divided by 10. So in the previous problem, we what was C that we found? We got C to be 0.41. Okay, so we can just substitute it here. So let's say this 0.4, so it becomes 1 minus, let's say, of 0.1 divided by under root of 0.21 divided by root 10. So once we solve this, we will get our power of the test. So what is this value? So this is coming to be 1 minus subset of 0.71 something, okay? So what is FC of 0.7? Let's look at the value.
Point 0.75, I think.
It is 0.75.
Yes. Point 0.758.
Okay, FC of 0.714, right? 0.7. No, it is coming to be something 0.57, right? This value is coming to be 0.57.
No, ma'am, that is 0.69 precisely.
0.69?
Yeah, nearing to 7, what you said, correct.
Ma'am, it is 0.69, ma'am. Hello.
Yes.
It is 0.69, ma'am.
This one?
Yeah, within the bracket of FG. Yes, within the bracket of FG, it is 0.69.
0.7. Okay.
Okay, here doesn't make much difference because 0.2, 0.69 I am getting within the bracket of FG.
Okay. This is 714. I am
Okay,
getting it to
no
be point.
problem.
Okay, but still, whatever is done in the
No, we can
lecture, we are not getting the right answer. So there we are getting the type 2. Okay, there we are getting beta to be 0.85.
Ma'am, they are accepting H0 in the lecture, ma'am.
There we are finding beta. I mean, so we know power is 1 minus beta, right? So beta is, we are accepting H0, probability of accepting H0, given HA is true. So given the alternative is true, still you are accepting your H0. So this is probability of making the type 2 error. And here this is coming out to be 0.85. So power should come out to be 0.15. So there is some calculation mistake here. Some calculation mistake. Okay, let's find the power beta first. Let's see if that is coming out to be correct.
Now, in this case, actually, we are getting the power as a 0.24 now, ma'am.
Sorry?
In this case, 1 minus 0.57 or 0.7 value, it is coming up to 0.7549, ma'am. Then it is coming to 0.24.
Yeah, that's what. So if let's first check whether beta is coming to 0.85 or not. Okay. So it is probability of accepting H0 So this is t is less than equal to c given p is 0.3 and this t is x bar less than equal to c, p equal 0.3. Now probability x bar minus 0.3 divided by 0.21 n less than equal to c minus 0.3 divided by 0.21 divided by 10. And this is fz of c minus 0.3 divided by 0.21 by 10. And since c is 0.41 something, I can, this will become, wait.
The probability of HA is true is 0.07.
So 0.41 minus 0.3 divided by 0.21. Still it is coming to a 0.76 approx. So FC of 0.76. So FC of 0.76. That is coming out to be 0.71.
No, ma'am. Earlier we have
Okay, it is 0.77, right?
yeah 75.7549.
It is coming to be 0.77 or 78.
75.
It is not coming to 0.75.
1 minus 0.75, ma'am, which is matching with the 0.76 now here.
So we are trying to find FC of 0.76, right?
69, ma'am. FZ of 0.69.
FC of 0.69.
Yeah, inside the bracket it is 69. That's what Gangana's that is also.
No, you calculate this. So C we had gotten to be 0.4. Okay. So 0.4. So it becomes 0.1 root 10 and divided by 0.21. Oh, it is coming to 0.69. Okay, sorry. All right, so it is coming to 0.69.
And then the value of 0.69 is 0.7549.
0.75. Yes, it is coming to 0.75. Still, we are not getting 0.85. Oh, something is wrong. So there will do. Okay, so this we got using the test statistic. Beta equal 0.75. This we got using t to be x bar. Let's see what we are getting using t equal x1 plus 2x10. Okay.
Ma'am, in lecture also beta they have got 0.23 only.
Sorry?
In lecture also they have got 0.23 only beta is equal to.
It is given to be 0.85, right?
No, it is 0.23 showing in the lecture for beta.
No, 0.85.
It is showing you 0.85. Okay.
Yes, beta is 0.85.
All right. If we are taking the test statistic to be x1 plus x2 up to x10, in this case, okay. So alpha was 0.05. That is probability you reject H0 given H0 is true. So this, let's say T is greater than C given P equal 0.2. Okay. And we know that the distribution of T is binomial with n equal 10 and P equals 0.2. Okay, P is not given, right? So this is P. This is our distribution of T. Now we reject H0 when T is greater than C. Okay. So this becomes this becomes 10 choose K. So it is sum over 10 choose K, P to the power K, and 1 minus P to the power 10 minus K. Okay. And K should be greater than C. T should be greater than C. C plus 1 till 10. Is it all right?
Yes, ma'am.
Okay.
Ma'am, I have not understood how
There-
it is C+1, ma'am.
Okay,
Ma'am.
so see, let's see the
There
one
we got.
step here. Yeah, so T is x1 plus x2 plus up to x10, okay? And this is greater than C. And
Yes, ma'am.
basically this models your binomial random variable.
Yes, ma'am.
So we are saying generally, let's say if this is, you denote it as y is greater than C.
Okay.
So how do you write probability y greater than C? It means the random variable is taking the value greater than C.
Yes, ma'am.
Right?
Ma'am, in the lecture, sir calculated the PDF of binomial directly, so it's getting 0.85. We are approximating it in normal.
Yeah, right. This can be one thing, yes. All right, so let's see. So this becomes 1 minus probability T less than equal to C, given P equal 0.2. And it is 1 minus sum over 10 choose K, P to the power K, 1 minus P to the power 10 minus K, okay? And K is varying from 0 to C. So there we had taken different different. This is 0.05. All right. So this becomes sum over 10 choose K, 0.2 to the power K, 0.8 to the power 10 minus K, K varying from 0 to C equals to 0.95. So how are we finding the value of C here is, we are going through, we are taking different values of C here. So we are putting different values of C and then finding like just comparing it.
Yes, ma'am.
Right. And from there we found that at C equals 4, when you take C to be 4, okay, and you sum it over. So when C equal 4, you can just cross check once. So when you choose C to be 4, so this becomes K varying from 0 to 4. 10 choose K, 0.2 to the power K, 0.8 to the power 10 minus K should be 0.95. All right, so here you have to just compare and find C. This is what we have done in the lecture.
Sir has used Google Colab to find out all those values.
So you can use the Google Colab notebook and just take different values of C and find the alpha, and then for whatever alpha you are getting the correct C, you choose that C. Okay. So here we had taken a very small sample. So the sample was just 10 people. Sample was just 10 people. So that's why we did not approximate here with normal distribution. We are just saying that this x1 plus x2 up to x10 is our binomial 10 comma p, and when from there we are getting our C to be 4, and our this x bar, this x1 plus x2 plus up to x10 was coming to be 3. And since this x bar, this t is less than C, so we were accepting RH0, right?
Yes.
Even the same result we obtained when we used the test statistic to be sample mean. Okay. We obtained the same result. We obtained it is except H0.
We got the same result now.
Yes, we got the same result. And when we find the type 2 error, so what we got is 0.75. We got our beta to be, we got type 2 error to be 0.75. But if you take test statistic to be sum of x's, you get your power, you get not power, you get type 2 error beta to be 0.85. So this has been calculated simply by taking C to be 4. So probability t less than equal to 4 given p equal 0.3. So substituting p equal 0.3 here, and taking different values of k is equal to 0 to 4, you add all this and you get this to be 0.85. So you'll have to calculate this value. Has anyone tried to calculate this? Has anyone tried to calculate this value? No. So what will you get? You'll get 10 choose k, 10 choose 0, p to the power 0, 0.7 to the power 10, plus 10 choose 1, 0.3 to the power 1, 0.7 to the power 9, plus 10 choose 2, 0.3 to the power 2, 0.7 to the power 8, plus 10 choose 3, 0.3 to the power 3, 0.7 to the power 7, plus 10 choose 4, 0.3 to the power 4, 0.7 to the power 6. So 10 choose 0 is 1. This becomes this 0.7 to the power 10. 10 choose 1, 10 times 0.3 times 0.7 to the power 9, plus 10 choose 2 is 10 into 9 by 2. So 45. 45 times 0.09 times 0.7 to the power 8, plus 10 choose 3 is what? 10 into 9 into 8 by 6. So it's 2, 3, 4, so 12, 120, right?
Yes.
So this is 120. 0.3 to the power 3, 0.7 to the power 7, plus 10 choose 4. How much is 10 choose 4? What is 10 choose 4?
It's 210, I
It is
think.
210. Yeah. So 0.3 to the power 4, 0.7 to the power 6. So if I take 0.7 to the power 6 to be common, it becomes 0.7 to the power 4 plus 3 times 0.7 to the power 3 plus 45 times 0.09. That is 4.05 times 0.7 square plus 120 times 0.3 cube. This is 3.24 times 0.7 plus 210 times 0.3 to the power 210 times 0.3 to the power 4. So this becomes 1.701. Okay. Now just solve this. I think you should be able to get 0.85. So 0.7 to the power 4. This is 0.2401. 0.7 to the power 3.
1.029.
0.7 to the power 3. Yeah, so it is 1.029. This becomes 4.05 times 0.49. 1.9845. 3.24 times 0.7 becomes 2.268. 1.701. Okay. So 0.2401 plus 1.029 plus 1.9845 plus 2.268 plus 1.701 times 0.7 to the power 6. Yeah, so we get approximate 0.85. So we are getting our beta to be 0.849 something. So approximately this beta becomes 0.85. Okay. So this is how the beta has been calculated in the lecture.
Ma'am,
Yeah.
it brings a doubt to mind. Like in exam, will not get Google Colab, right? So if we come across this kind of problems, whether we should take a normal approach or we should go by binomial approach.
See, you should go by here. The sample that was taken was quite small,
Very less, very less,
very
yes,
less,
yes.
right? So, so this problem is again taken with a larger sample. In all the question that you solve in the graded or practice, all the samples are big enough to use so that you can use the normal approximation. So here it was just to show, like, if the sample is small, we took different test statistic, and when the sample is quite big enough, so in the next problem what we have done, the problem is still the same, that your h0 p equals 0.2, and you have to check whether p is greater than 0.2.
Yeah.
And
Sample size has been increased.
Yeah, the sample size rating to be 100, and from there we found out that 28 of them are vaccine hesitant. So basically x bar is 0.28.
Right.
And the way we have solved the first problem, that is this problem, right?
Normal approach, yes.
Yes, normal approach. We will solve the same way, and we will get, and we are getting our alpha to be C to be 26.58 from there. Okay, so since C is 26, this you can calculate. You all can calculate, right?
Yes, yes.
So you're getting C to be 26.58, and since the test was to reject H0, given H0 given T is greater than C. So here T is not coming out to be greater than. Okay, test was reject touch H0 when T is greater than C. Okay, so here T is coming out to be greater than H0. So we are rejecting H0, right? We are rejecting H0. And similarly, we will find our beta. Any doubt in this problem? Like the second problem is still the same, it's just we are increasing the sample size.
So ma'am, can we conclude a thumb rule that if sample size is greater than 30, then we have to follow this normal approach, right? Irrespective
Yeah,
of
if the sample size is big enough, you approximate, you know, using CLT data, it can be approximated using normal.
that x bar minus expected value of x, right?
Yes.
Divided by variance, square root
Yes.
of variance, right?
Yes.
So we have to follow that approach, huh?
Yes, if the sample size is big enough, you have to follow that approach.
Irrespective of the distribution, whether my population or sample
yes, using
is falling.
CLT. Yeah.
Yes, okay, ma'am. Thank you.
Any doubt in this problem?
Not in this question, ma'am, but in that lecture only, lecture number 8, professor has solved, I think, problem number 2 or 3, where he is talking about striking a balance between alpha and power. Alpha and power. So could you please explain that concept?
Okay. Wait.
I think this is problem number 2 or problem number 3, something like that, where he's talking about striking a balance between alpha and power.
Is it which problem you're talking about?
I think it is problem number 2, ma'am.
Problem number 2, okay.
Yes, ma'am, 2 only, where he's talking about striking a balance between alpha and power, how to take a decision.
Okay. So here the problem says, so this is 2.A, okay. The current carrying capacity of a resistor manufactured at your company is supposed to be 3 ampere. Now, because of a recent change in the manufacturing process, you suspect that the current carrying capacity might actually be lesser than 3 ampere. You decide to test by measuring current carrying capacities of 10 resistors with a test measurement has a standard deviation of 0.05. If the sample mean of the test measurement T10 is less than 2.95, you will conclude that the manufacturing process is faulty. Okay. So in this problem, what was the null hypothesis? The samples are coming from so H0 is, you're assuming that the current capacity is supposed to be 3 ampere. So we are assuming that mu equals 3 ampere. And since you have made a changes, and now you suspect that the current carrying capacity is less than this. So mu is less than 3 ampere. Okay. So this is an alternative. To test this, you are taking 10 resistors, and each are coming from a distribution whose standard deviation is 0.05. So x1, x2 up to x10, you have 10 resistors, and we are saying that they are coming from a distribution whose standard deviation is 0.05. If the sample mean of the test measurement, so sample mean x bar okay. So again, here we have 10 samples. Can you all look at the slides? Should I share the slides here?
Yes, ma'am. Yes, you can do that.
Okay, let me share the slides first. Okay. So here the problem statement says the current carrying capacity is supposed to be 3 ampere, right? And because of a recent change, you suspect that the current carrying capacity might actually be less than 3.8. So you know the null we are going to take is 3 ampere, mu is 3, and alternative is going to be less than 3. Is there a doubt in identifying the null and alternative here?
No, ma'am.
Okay. So to check your hypothesis, you are taking a sample of 10 resistors with a test measurement has a, so you are taking 10 resistors, and we are saying they are coming from a distribution whose standard deviation is 0.05 ampere. All right. Now, if the sample mean of the test measurement is less than 2.95, you conclude that the manufacturing process is faulty. So what do you mean by saying that the manufacturing process is faulty?
We reject.
Sorry?
We reject the null hypothesis.
You're saying we reject the null hypothesis.
Yes.
Will not accept the new manufacturing process. Will go by the existing manufacturing process.
No, sorry, ma'am. Actually, I think the null hypothesis will be that it is less than 2.95.
Can you repeat?
I'm saying that I think the null hypothesis should be that it is less than 2.95.
No. Null is a 3
No.
only. Null is 3 only, and alternate is less than 3. And this 2.95 is, I think, critical value.
2.95 is the critical value, right?
Yes, 2.95 is the critical value.
Yes. So we are saying if the sample mean comes out to be less than 2.95, you conclude that the manufacturing process is faulty.
Yes, the new one which has been designed, that is faulty. Yes. Yes, ma'am.
Yes. So what is the test?
Test is also given, ma'am. P less than 2.95.
It's a left tail test, ma'am.
P is
Yes,
equal
yes.
to 2.95.
Test is left tailed. But I'm asking, okay, so before going to the test, what is test statistic that we're using here? What test statistic are we using here? It is given in the last statement. Please read the last statement carefully.
The sample mean of the test is T10 is less than 2.95.
In the last statement, it is written out if the sample mean of the test measurement is less than 2.95.
Sample mean is test statistic.
So what is the test statistic?
Sample mean.
Sample mean. Is everyone okay with it? That we are taking this
Yes,
test?
sample mean, yes.
Yes.
Okay. Okay, so the test statistic P is X bar, and the test is that you reject H0 given X bar is less than 2.95. So H0 is given to be mu equals 3 ampere, right? And it is a left tail test, and we are saying if your X bar, if your test statistic falls below 2.95, we will reject the null hypothesis. We will reject the null hypothesis. Say means that
your screen is not visible, ma'am.
My screen is not visible.
Means what you are writing.
Are you writing
we are
something?
on.
No, I'm not writing anything.
Yes, yes. Then it is visible. Yes.
Okay. So yeah. So saying that you are rejecting H0 if your X bar is less than 2.95. So if your test statistic value lies below this critical value, we are saying that we are rejecting H0. It means we are saying that there is a fault in the process. So what is the first statement says? It says the current carrying capacity of a resistor manufactured at your company is supposed to be 3 ampere. Okay, so it should be 3 ampere. The current carrying capacity should be 3 ampere. Okay, but if it falls, but because of a recent change, you suspect that it is less than 3 ampere. Okay, and we have found a critical value that is 2.95. So there is a critical value given to you, and we are saying that if your sample mean lies below this 2.95, we will say that we are rejecting our H0. It means rejecting your H0 means mu is less than it means mu is not equal to 3 and mu is less than 3 actually. So there is a fault in the process. Is it clear like why we are taking the test to be reject H0 when sample mean is less than 2.95? So
Yes.
this is given in a problem statement properly. The first line you read the way we have taken the null and alternative, and the last statement.
Ma'am,
Yeah.
the test mean is less than 3. Whatever the explanation you had given now is not really flowing through. That is
Okay.
not
Wait,
able to get it.
I will share. I'll share the screen. So we were saying that the current carrying capacity should be ideally 3, okay? Should be 3 ampere. But there is a recent change and it has been observed that it might be less than 3 ampere. Okay, so that you want to check whether it is 3 or it is less than 3 actually. So we had defined our H0 to be, since it is supposed to be 3 ampere, we are defining our mu to be 3, and our alternative is going to be mu less than 3, because this is what we want to check if it is actually less than 3. Now, what is additionally given in the problem is, like, if your sample mean, if you have taken a sample of 10 resistors, okay, you have taken a sample of 10 resistors and they are coming from a distribution whose standard deviation is 0.05. Now, in the problem itself, it is given that the test is you, like, if your sample mean falls below 2.95, you will say that there is a fault in the process. There is a fault in the process. Okay. It means we are actually accepting the alternative hypothesis. And by accepting the alternative hypothesis, we are rejecting our H0, right? So if you plot the graph, let's say this is our 3 ampere, and the critical value comes out to be 2.95. 2.95 is the critical value, and we are saying if the sample mean, so if this is a distribution of the sample mean, if the sample means comes out to be less than 2.95, okay, if the sample mean comes out to be less than 2.95,
I mean, it's just because standard deviation is 0.05. So we are assuming that there are opportunities to have samples less than 2.95. Is that right? That's the way you're reaching out?
No, it is given in the problem. This 2.95 is given in the problem.
2.95 is given in the problem.
Yes.
But how are you connecting that standard deviation 0.05?
I'm not connecting standard deviation anywhere.
Okay, then so it's a coincidence that 3 minus 2.95 is 0.05?
It is a coincidence here.
Right, okay.
Okay, yeah. So what is said in this question statement is, if the sample means comes out to be less than 2.95, we are saying that there is a fault in the manufacturing process. Okay. So by saying that there is a fault in the manufacturing process, it means that our mu is coming out to be less than 3 ampere. Because it is supposed to be 3 ampere.
Right.
Right. So saying that there is a fault in the process, it means we are accepting H0. Sorry, we are accepting our alternative, accepting our alternative. And by accepting alternative, what do we mean? We are rejecting our H0.
True.
So the test basically is.
So we have not done any math now. We are just reading out the statement and.
Yeah, we are just reading out the statement. So the test is reject H0 if this X bar is less than 2.95. And this 2.95 is nothing but your critical value.
Right.
Okay. Now we look at what the question statement is. what exactly you have to find there. So the first problem was, what is null hypothesis, what is alternative hypothesis, and what are the sample. So we found that the null hypothesis is mu equal 3 ampere, alternative is mu less than 3 ampere, and what are the samples? Sample are x1, x2 up to x10, right? So first question we are done. So this was the first problem. Now the second question is, what is the significance level alpha of the test? How do you find the significance level now? How do you find the significance level now?
And we use that equation for alpha and we'll put all the values when C value is given, right? Yes, this formula, probability of
reject H naught.
Yes.
Reject H naught if
the mu equal to 3.
Value is less than 3.
Mu equal to 3, yes.
Right. And we are taking T to be X bar. So X bar will approximate to this normal with mean mu and variance. So
0.05.
it is given to be 0.05
square
divided by 10.
Ma'am, here sample size is only 10, but then how come we are taking normal approach?
It is already given in this problem statement that we are taking the test to be a test statistic to be sample mean. Here it is given the problem statement, right? Like if the sample mean comes out to be less than 2.95, we are rejecting the null. So if we are using the sample mean to be test statistic, then it is approximating to this only. So X bar is approximating to normal with mean mu and variance sigma square by n. That is 0.05 square by 10. So even if you like in the previous problem, we saw that even if we took either the sum of the random variable as a test statistic or the sample mean, accepting or rejecting null, like the final conclusion came out to be correct. I mean the same. Right? So from here you can find your alpha, and this becomes probability that this T, that is X bar minus mu divided by 0.05 square by 10 is less than C minus. So C is 2.95. So 2.95 minus 3 divided by 0.05 square divided by 10. And from here you got this to be fz of 2.95 minus 3, 0.05 divided by root 10. So this is a alpha. This is a significance level that we obtained.
Ma'am, is this what they call a p-value test?
A what?
P-value, like once, like we have seen two types of problems, basically one where we are given alpha at the beginning and where we calculate the critical value, and on the basis of which we accept or reject the hypothesis.
Here we are not trying to find.
But here, like we are asked to find the alpha. So I'm just wondering.
No, the question was given. The second question that was asked: what is significance level of the test? So to find the significance level of the test, we need to find the type 2 error. Sorry, type 1 error. That is alpha. So this is what we just found here. What is alpha? What is the significance level of the test? P-value is a different thing, right? P-value is the lowest significance level.
Okay, ma'am. Thank you for clearing that. Thank
you. So,
Madam, can you repeat the part you said about the t-value is the minimum significance? Means like what we are willing to accept, the 2.95 is the minimum. Is that what you mean?
No, here we're not talking about p-value. In this problem, we're not talking about p-value at all.
Okay.
We are just saying 2.95 is the critical value. And if your sample mean lies below this 2.95, we are going to reject our H0. That's all. And since the critical value is given in this problem, we have to find what is our significance level. So that is given by alpha, that is probability t less than c given mu equals 3. And from there we found alpha to be f set 2.95 minus 3 divided by 0.05 divided by root 10.
So if I know a significance value, I can use the same approach to find out the critical value. Is that correct?
Yes, that is correct. If the alpha is given, you find C. Now here C was given, now you're finding alpha.
Alpha, okay. Okay, thank you.
Now the third problem that is given here, if the current carrying capacity falls to 2.9 ampere, there could be a serious safety issues against the alternative hypothesis of 2.9 ampere. What is the power of the test? Okay, so to find the power of the test, we need to find the beta. So to find the power of the test, we need to find beta, and beta is probability of, so given HA is true, given your alternative is true, you are accepting your H0. So accepting H0 means probability X bar greater than equal to 2.95 given HA is 2. So in the problem it says if the current carrying capacity falls to 2.95, there could be a serious safety issue. So against the alternative hypothesis, so if you take alternative to be, so initially mu was mu equal 3 and your alternative was mu less than 3. So if this alternative becomes 2.95, so if mu equals 2.95, what is the power of the test? Okay.
And it is 2.95 or 2.9?
Okay, sorry, 2.9. Sorry, just 2.9. So against this alternative, so if you take the alternative 2.9, what is going to be the power of, beta? So again, you can find the same way. And
ma'am, 1 second. Ma'am, mu is equal to 2.9. He has given it, ma'am.
Mu is to be 3, so, I think.
Yeah, mu is 3, but okay, to find beta, so what does beta says? It says probability that you accept H0.
I will accept H0 when my
given
mu is
HA
3.
is true. Given
Yes,
HA is true.
Yes,
right?
ma'am. Yeah.
Given HA is true. Now, what is H0? H0 is mu equals 3 and HA was mu less than 3.
Yes, ma'am.
So it is just given mu is less than 3. But there is no fixed value what mu is.
Okay.
Right? So for that, we need a particular value of mu. And in the problem, it is given that against the alternative hypothesis of 2.9 ampere. So if you take HA to be mu equals 2.9, then what is the power of the test?
Okay, ma'am. Okay, understood.
Ma'am, one small doubt, ma'am. We are accepting null hypothesis when mu is 3 or greater than 3, right? So here accept H0. So probability of X bar greater than 2.95 or greater than 3. What we should write, ma'am?
No, it is. See, it is always T less than.
No, okay, got it, ma'am.
Got it, right?
Is a critical value,
it's
right?
It's the critical value. It is the critical value.
Blunder, ma'am, sorry.
Okay, so similarly, you can just in the last problem, mu was 3. Now here you substitute mu to be 2.9 and you solve this, and you will get something to be 0.0078. This is what we are getting. This is beta. Now to find the power, we need to subtract this from 1.
Ma'am, I have a doubt here.
Hmm.
Ma'am, when we tell it is X bar is greater than or equal to 2.95, condition mu is equal to 2.9. So in that case, it is 1 minus FC of that we need to do, no ma'am?
Yes, 1 minus FC.
Yeah, then that beta is 0.078 we get, right?
Yes, yes,
Okay,
yes.
ma'am. Okay, ma'am.
Like after calculating everything, we are getting beta to be 0.078.
Okay, ma'am.
Ma'am,
Huh?
even professor has used Google Colab to find FG inverse also, right? So
Huh.
in examination, whether FG inverse value will be given or how?
All the values will be given. All the values will be given.
Even FG inverse also, right?
Yes, yes, everything will be given.
Okay. Because yesterday we learned how to find out with the help of jet table, right? So I was just asking whether jet table will be given or the value itself will be given. The values are given.
Value itself will be given.
Thank you, ma'am. Thank you.
Madam, in the graded assignment also FZ values are given, but I have not
Some
solved all
of
the
them
problems.
are not given.
Yes, I wanted to ask that. So we can use the Z table from the internet and it's okay, right?
Yes, yes, it is okay.
Okay,
Like for the assignments and all, you can always use the internet, right? But in the exam, all the values that is needed, that will be provided to you.
Okay. So if we,
Yeah, so this was about the first part of the question. The same problem, you have the second part, and it says, suppose you can test n resistors. If the sample mean is less than C, you conclude that the manufacturing process is faulty. You need to determine suitable values for N and C under the following condition. Okay. Should I show the question here?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. So continuing the same problem, now here you have, like if you can test n resistor. Okay, now initially we had just tested 10 resistor, and from there we said that if the sample means comes out to be less than 2.95, we are going to reject the null hypothesis. Okay, but here we are testing, let's say, n resistor, and if the sample mean comes out to be less than C, here there C was given to us 2.95, but there C is not given, critical value is not given. We are simply saying if the sample mean comes out to be less than the critical value, we will conclude that manufacturing process is faulty. It means we will reject the H0 if X bar is less than C. Okay. Now you need to determine suitable values for N and C under the following conditions. So the first condition that is given is significance level or probability of type 1 error alpha is less than equal to 10 to the power minus 6. So if the alpha is less than equal to 10 to the power minus 6, you have to determine what are the suitable values of N and C. Okay, so the same thing, the test statistic here is sample mean. Test is reject H0 if X bar is less than C, and we know this that X bar is going to be normal with mean mu and variance sigma square by n, that is 0.05 square by n. Till here it is fine. Now using the significance level, that is probability of making type 1 error, you know that probability X bar less than C given mu equal 3. So once you calculate this, once you find the significance level, that you will get in the form of FC of C minus 3 divided by 0.05 divided by root n. So we are saying in the first case that a type 1 error probability should be less than equal to 10 to the power minus 6. Okay, so basically this C should be less than equal to 3 plus 0.05 divided by root n minus 4.753. Okay, so this C value should be less than this particular value that we have got here. And again, in the second problem, we are saying probability of type 2 error should be less than equal to 10 to the power minus 12 against an alternative of 2.9 ampere. So we will find type 2 error, and we found type 2 error to be 1 minus FC of C minus 2.9 divided by 0.05 divided by root n, and this should be less than equal to 10 to the power minus 12. So this particular, after solving this, we got C to be greater than this particular value. So we will have to solve these two particular equation 1 and 2 to get the value of n and C. Okay. So let's try to do this problem now. Okay. So till here it is same thing. In the previous problem, we already had the critical value that was 2.95, but in this problem, we don't know what the critical value is, and we have to find this critical value, and we also have to find the value of n. And we are taking a sample of n resistors. So x1 to xn, they are coming from some same thing, like coming from some distribution whose standard deviation is 0.05. So if the test statistic is x bar, the test statistic is x bar, this is again following the normal distribution with mean mu and variance 0.05 square by n. Now using the alpha, so the first question was significance level or probability of making type 1 error, alpha should be less than equal to 10 to the power minus 6. Now, if we try to find the value of alpha, so alpha is probability of making a type probability that with x bar is less than c. So x bar is less than c given mu equals 3, correct? And this is going to be x bar minus mean, that is x bar minus 3 divided by 0.05 divided by root n. It should be less than c minus 3 divided by 0.05 divided by root n. And this comes out to be fc of c minus 3 divided by 0.05 divided by root n. And this is your alpha. And from the question, it says alpha should be less than equal to 10 to the power minus 6. Okay. So this should be less than equal to 10 to the power minus 6. Okay. So it becomes c equals 0.05 divided by root n, fc inverse of 10 to the power minus 6 plus 3. Sorry, c should be less than equal to this. This is clear? This,
yes,
this is clear, right? Okay. Now let's go to the second part.
Madam, just sorry, I was trying to ask. I didn't realize I was muted. The inequality, where is it coming from, madam?
From here, alpha is
alpha. Okay, sorry. Got it.
Okay. Now in the second part, it says your beta should be less than equal to 10 to the power minus 12 against an alternative that mu is 2.9. Okay. So beta is probability that you are accepting H naught given that H is given that H is true, right? So given alternative is true, still you are accepting your null hypothesis. So probability of accepting null given HA is true. So this is going to be accepting H naught means your X bar should be greater than or equal to C given mu equals 2.9. And this becomes 1 minus FC of X bar minus, sorry, no, not X bar, C minus 2.9 divided by 0.05 divided by root n. Okay, and we are saying this should be less than or equal to 10 to the power minus 12. Now, once it goes to the other side, so 10 to the power minus 12, we can take it on this side. So 1 minus 10 to the power minus 12 is okay. So minus of FC of C minus 2.9 divided by 0.05 divided by root n is less than or equal to 10 to the power minus 12 minus of 1. Okay. So you change the minus sign, your inequality sign changes. So it is 1 minus 10 to the power minus 12. So it will be approximately equal to 1. This 1 minus 10 to the power minus 12, right? So from there we get C to be greater than or equal to C to be greater than or equal to 2.9 plus 0.05 divided by root n FC inverse of 1 minus 10 to the power minus 12. Right?
You're multiplying both sides by -1, madam.
Yeah, we are multiplying both sides by -1. So your inequality sign will change, right?
Yeah,
so
yeah.
if it is less than, it becomes greater than or equal to. So here C minus 2.9 is greater than or equal to FC inverse of 1 minus 10 to the power minus 12.
Okay.
Okay. And this is what we get. Okay. Now we have to compare both these equation 1 and 2. So this FC inverse of 10 to the power minus 6, if you calculate, you can use this Python code and you will get this value to be minus 4.753. Okay. This you will get, can you mute? So FC inverse of 10 to the power minus 6, if you calculate in the Python, you will get this value to be minus 4.753. In the normal distribution, there you cannot, there it is mostly from -3 to 3. So you cannot find this value using this table. And similarly, this thing, this value will come out to be 7.034. Okay. So we are directly substituting this value. We'll just directly substitute this value. So let's see. The first equation was C should be less than or equal to 3 plus 0.05 divided by root n of minus minus 4.753. Yeah. And the second equation was C should be greater than or equal to 2.9 plus 0.05 divided by root n of 7.034. So these were the two equations. Okay. So let's denote this by, if I'm saying the upper critical value and this is the lower critical value. So C upper critical value and this is the lower critical value. So our C should be less than equal to this and it should be greater than equal to this this lower critical value. Okay. So you see that there is a equality sign here. There is also an equality sign here that C is equal to this and C is equal to this. So we can just solve these two equations and we'll get 3 plus 0.05 divided by root n of minus 4.753 equal to be 2.9 plus 0.05 divided by root n 7.034. All right. So this becomes 0.1 equal to 0.05 divided by root n of 7.034 plus 4.753. And after you solve this equation, you get n to be 35. So are we getting n to be 35? Let's check. So 7.034 plus 4.753 into 0.05. So this becomes 0.1 root n equals 0.58935. If you divide it by 0.1, it becomes under root of n equal 5.8935. And to find the value of n, you will have to square it. You square it, you get n to be 34.733. So n is approximately 35. So we got the value of n to be 35 here. Huh?
One equation is less than equal to and the other one is upper greater than equal to, right? So the overlapping regions should be taken, right?
Overlapping regions will be taken, right?
So how we have equated how we have equated both these two equations, man?
So how have we? So it is less than one is less than equal to, other is greater than equal to.
So it means overlapping region.
Yes. So at one point, they both are going to be equal. They are coming to be equal.
Okay. So that is the reason why we have
So
equated.
then in both you have equal to sign also, right?
Okay. That is the reason why we have equated, right?
Yes. Yes.
This kind of question will come in n term.
No.
That we cannot do.
Ma'am, how come we are taking every time we are taking help of Google Colab to solve the problem? How we will able to do, ma'am?
No,
that's
problem. What I'm saying. The Fset value that is needed, that will be provided in the problem. That is not an issue.
Even then also very, very tough to solve.
Madam, I have a question.
One suggestion, ma'am.
Yeah.
Madam, the question is on the range that you have picked. So the n value will hold for the entire range that you said that you shaded?
CLV and CUV. Yeah.
So it'll
by
hold for
equating it, we will be getting optimally L value.
So
my question
optimum,
is about
yes, that's what I am saying. By equating these two values, we will be getting the optimum n value. So that the C could be optimum. Both C's could be optimum for max n.
Okay. May I continue now?
Yes.
Yeah. So once we get this n value, can we substitute the value back in C and then when we do that, will we get only one C value or will we be getting the LV and the upper value and lower bound?
See, taking this n to be 35, you got this by equating both of these c to be equal.
Correct.
Right. So let's do this. So if you put n to be 35, okay, so you will get this to be 0.05 times minus of 4.753 divided by under root of 35 plus 3.
Your screen is not visible, I think.
It is visible, right?
Screen is visible. Whatever you are writing is not.
I'm calculating in the calculator. Okay.
Okay. Fine.
So this you are getting c to be less than equal to. Okay. So we are taking this. We are writing this to be c of ub. So c of ub comes out to be 2.9598 something. Now let's calculate c of lv. So 0.05 times 7.034 divided by root 35 plus 2.9. So again, you are getting this to be 2.95944, right? So you're getting both the C to be equal. 2.95, 2.95, basically. Or you can say C to be 2.96.
Okay. When do we get the LV and CV?
When do we get LV and CV? So see, this is just a notation that I have written here. So solving these two equation 1 and equation 2, we got our C to be less than this value and C to be greater than this value. So what I'm saying is this value is, let's say I am denoting it as C of UV. Okay, we are saying C should be less than equal to C of UV, that is some this reason. And from the second equation, we are getting C to be greater than equal to C of LV. So that is some this reason. Okay, but at some point, both the C's are going to be equal. So we are substituting these two C values and we are getting N to be 35. So we are saying at N to be equal to 35, we are getting our C to be approximately 2.95.
Right.
And this C value is matching with the C value given in 2A. So it's a coincidence or it's a continuation of that value? But there also
that C value only to both equations will hold.
Yes, this C, like only after substituting N to be 35, we are getting C to be 2.96 here.
So the root 30, I mean, n is equal to 35 will be at the equidistance from both of these two values, now upper and lower.
No, we are saying at this, like if you take the sample size to be 35, we are getting the critical value to be equal to 2.96.
That is what n is equal to 35 is equidistant from these 2 points, ma'am. While we are equating, that is the meaning, ma'am.
Need not to be equidistance, no? I mean, we are just saying like both the C's are going to be equal at some point. This is all we are saying. So we can solve it. We can solve it, and from there we are finding this n value. So it means for this n value, we are getting this critical value 2.96.
So, madam, if I really, maybe I'll be putting it in some too simplistic a term, which may be wrong. But the above equations, two of them, they are practically simultaneous equations.
The above two equations are simultaneous equations. What do you mean by that?
Basically, if y is equal to, 3x plus 2y is equal to 4 or something like that. That's exactly what it is, isn't it? One is C, other is
let's say x is greater than equal to 4y plus 3, and we are saying x is less than equal to 4 some y plus something, y plus let's say 5. So if you have to find the value of x and y, what you will do, you will just, since there is an equality sign here, so it means you are going to solve for 4y plus 3 equal y plus 5, right?
Correct.
To find the value of y, and once you find the value of y, we are going to find the value of x.
Yeah. Okay.
Yeah. So we just found like a suitable value of under these two conditions. So basically under the condition when alpha is less than equal to 10 to the power minus 6 and beta is less than equal to 10 to the power minus 12, we are getting a value of n to be 35 and c to be 2.96. That is all. So there is one more problem left. Okay. So in the next problem again, you have to check how will the sample size, you have to find the sample size. Okay, let's see. So in the next problem, the problem is the average CGPA of students in a college is reported to be 8.0 with a standard deviation of 1. So somebody has reported the average CGPA of students in a college to be 8. Okay, so we will take H0 to be mu equal 8. You suspect that the average may be lower, possibly 7.5, and decide to sample students to find the CGPA. Now, suppose you suspect that whatever has been reported is wrong, and the sample, like the average marks, the mean marks, should be less than 8. Okay, this is what you suspected. So what you're going to do now, you are going to take some sample of students and you're going to find their CGPA. Okay, so what sample size do you need for a test at a significance level of 0.05 and the power of 0.95? All right, so standard deviation that was given was sigma equal 1. Now what you have to find is what is the value of n. So given the significance level is 0.05 and the power is 0.95, what is going to be the size n? What is going to be the sample size n? So again, we are going to use our z-test here. So we are using the z-test here because we are testing for mean. So using the formula for significance level, we know that 0.05 is going to be probability. Let's take this test statistic to be sample mean. Probability that your sample mean is less than C given mu equal 8, right? And now this P, probability x bar minus 8 divided by sigma upon root n. So sigma is 1. So 1 upon root n basically. And it is less than C minus 8, 1 divided by root n. Now this becomes 0.05 equals FC of C minus 8 root n. Fine. And FC of 0.05 is nothing but minus 1.65, and this is C minus 8 root n. So C becomes C equal to 1 upon root n of minus 1.65 plus 8. Okay, so this is the one equation. Now you want the power to be 0.95. So power is 1 minus beta. And the way we define power is like given the alternative is true, still we are
Except the null.
Reject the
Reject the null hypothesis.
for 1 minus beta.
1 minus b, reject the null. Yeah.
Beta is probability that
Except the
given
null.
HA true, we are accepting
Accepting
it.
null hypothesis. Yes, that is
Accepting
beta.
it.
Yes, that is
So
beta.
1 minus beta is going to be probability that you accept H0, sorry, reject H0, reject H0 given HA to be true. Okay. And this is given to be 0.95 and it is going to be probability reject H0. So X bar less than C given
Greater than C.
so you have observed it was 7.5. So 7.5. It was given in the problem. Okay. So the problem statement, it says that you suspect that the average may be lower, possibly 7.5. So this is what you're suspecting, that this mu is going to be 7.5. So given this alternative is mu 7.5, probability that X bar is less than C. Now it becomes 0.95 probability X bar minus 7.5 divided by 1 upon root n less than C minus 7.5 divided by 1 upon root n. Okay. Again, 0.9 FC of 0.95 is 1.65 and this is equal to C minus 7.5 of root n. So your C becomes 1 upon root n of 1.65 plus 7.5. So now you have these two equations here and we'll have to solve the value, find the value of C and N. So we have these two equations and now we'll solve these two equations. Okay. So to solve this, we'll get 1 upon root n minus 1.65 plus 8. So you take it on the other side and it becomes 2 upon root n of 1.65 equal to 0.5. So 1.65 2 times 1.65 is 3.3. So 0.5 root n equals 3.3. So root n is going to be 3.3 divided by root 5. So n is going to be 3.3 divided by 0.5 square. So this divided by 0.5, you get 33 by 5 square and it becomes n to be 43.56. Okay. So n is going to be n equal 44. So for n equal to 44, it means for the sample size equal to, you are going to take the sample size to be 44 so that your significance level becomes 0.05 and power becomes 0.95. So once you found the value of n, you can easily find the value of C. You put it in any of the equation and you will get the value of C. Now in the second part, it says how will the sample size change if you suspect the CGPA to be 7. Now instead of 7.5 here, if you suspect it to be 7, this equation is going to change. So we're going to get 1 by root n 1.65 plus 7. So it becomes, in place of 7.5 becomes 7, right? So this becomes 1 and this becomes root n equals 3.3. So you're getting in the second part, you will get n to be
22.
10.89. So n equal something 11. Right? Yeah. So once you change, like from the alternative mu equals from when mu was 7.9, when you suspected mu to be when you suspected mu to be 7.5, your n came out to be 44. But when mu was 7, n came out to be 11. So basically, you need a sample of size 11 to say that mu equal 7. I mean, sample of size 11 to say that your significance level is 0.05 and power is 0.95. Is the problem clear?
Yes, ma'am.
Yeah.
Ma'am, in first case, by putting n equal to 44, we can also calculate critical value, right?
Yes, you can find the critical value. Also,
Sorry, continue, please, continue.
So I was saying also in week 11, there's a GeoGebra applet that has been uploaded. So that was, so have you seen the applet yet?
Not now, ma'am. We are just going through lectures.
So once you go through the lectures and you do the problems, just go through it once. Like I would suggest go before this solve with the session that is on Saturday. So if you go through the applet, we can discuss it on Saturday. Okay.
That is what on graphical representation or what?
Yes, graphical representation, like how is the sample size varying, how is the critical value is changing, like all that. Okay. So go through it and check. We can discuss it in the next session.
I have one question.
Is it in the week 11 regular menu? Is it in the week 11 regular menu or somewhere in the additional?
It's in week 11. It's in week 11.
Applet, huh?
Yes, GeoGebra applet. I will show you here.
Madam, while you are at it, sum of significance and power, should it be equal to necessarily equal to 1, madam?
It may not be 1, like not like here we have taken like alpha to be 0.05 and power to be 0.95, but it not be equal to 1. Okay. We are saying the lower the significance value, the power should increase.
Okay.
See here you have a GeoGebra applet. So you go to the link. We'll just close all this. So, okay. You can click on this alternative distribution, you will get your alternative distribution. You click on this, you get your type 1 error. You click on this, you get your type 2 error. You change the value of n and you see how is the alpha and the beta value are going to changing, right? So we're changing the value of n, your alpha and beta is changing, you are changing. Always you can check, okay? So I'm not going to discuss it today, just to show you. You go and try it on your own first and then we'll see, all right?
What do we focus on this simulation? What do we really get to see that? So you're telling about alpha plus beta should be as low as possible. That's what you're trying to.
No, this is a different thing I'm trying to say. I mean, that was a different discussion. This is a GeoGebra applet. So I'm saying here you have different distributions. Okay, so you can change your mu naught. Okay, you can change your mu naught, and so this green line, green graph, green normal, this is for mu naught. That is null hypothesis. And here you have alternative distribution. So you have an alternative hypothesis here.
Okay.
Then you click on here, you get your probability of type 1 error. You click here, you get probability of type 2 error.
Okay.
Also, how the value of alpha and everything is changing. You can see the graph, right? It is different. It is varying.
Okay.
Yeah. So what I'm saying, I'm not trying to show anything right now here. I'm just saying that there's a GeoGebra applet that is like this. You go and just try to see everything, like what exactly it is, and then we can discuss it in the next class.
Thank you, ma'am.
Okay. So this is just for a visualization. So you can try it out. If something is not clear, we'll discuss it in the next class. Since none of you have seen it, it would be good if you first do it on your own.
Ma'am, we had put a request for the assignment submission date, ma'am, because 24th we are having a proctored, ma'am, and the same day is the deadline for the assignment. So could you please look into that and give an extension for a day, ma'am?
Yes, but see, week 10 you already had a big deadline, right?
Yes, ma'am.
That is why it has been like week 10 was extended, and a lot of live session happened before the week 10 submission.
Yes, ma'am.
So we were expecting that to.
Ma'am, there is a technical problem also. Dashboard remains unfunctional for most of the times on that day.
Oh, is it?
Yes, dashboard does not open.
Okay, if that is the case, then we can see if something can be done. Otherwise,
just a 1 day, ma'am. Just on Monday, next day, if you give, that would be really helpful.
Okay. Let me check. Like if that is the case that it stays inactive, then
This request has been raised to both ma'am, Mayur sir and Srikant sir also. Both.
Yeah, I got to know that, but we thought since you already have a lot of time before. So
but this is a technical problem for that, ma'am.
Okay, so we'll talk, and if it can be extended, we'll extend.
Okay.
Otherwise, we'll notify you. We'll send an announcement.
Okay, ma'am. Thank you.
Okay. Yeah.
Thank you very much, ma'am.
Yeah, thank you.
Ma'am, I have a small doubt. You can go through that and we can discuss on Saturday also, ma'am. I think in week 9 or week 10, we talked about bias, risk, and variance, right?
Bias variance
9,
trade-off.
Correct.
Week 9, right?
Hello. Am I audible,
Yes.
ma'am?
It is week 9.
Am I audible, ma'am?
You are audible.
Yeah. I think it was in week 9, right? So during solve with us session, the first question was to find out risk, right? So we took the approach that risk equal to Bayes square plus variance. However, in definition, risk is also defined as expected value of square of error.
This we had discussed with you.
No, I had asked ma'am, when you said to try to solve it. So I tried to solve it. I'm not getting the answer, ma'am. Same answer.
I had asked you the same day, and you said it is okay for you.
No, I had asked this question on that day itself. Then you told we will get the same answer. You try to solve it. So I tried to solve it, ma'am. I'm not getting the same answer.
Okay.
So that is the reason I'm asking. Even you can solve it and we can discuss on Saturday. Not now, not necessary.
Okay, fine.
Because
just remind me on that day, okay?
On that day, yeah, sure. So just look into that problem, ma'am. The first problem of week 9 solve with us, right?
Yeah. Okay.
Yeah, we have taken the approach risk equal to Bayes square plus variance, but risk is also defined as expected value of square of error. So if I take that approach, then what will happen, right? That is my question, ma'am. Thank you.
Okay.
Thank you, ma'am.
Thank you, ma'am. Good night.
Yeah, good night.
Thank you.
Thank you, ma'am. Good night.
Good night.